Okay, here is the rest of the Newton's third law of motion conversation in Chapter 5. We have looked at forces and interactions. Now we're actually looking at Newton's third law. And we're going to review and we're going to look at how what we have been doing up to this point has been a little bit simplified, because we learned earlier on that a force equals a push or a pull. We did that practically on the very first day. And up till now, the problems that we have been looking at have been just this unnamed force coming and acting on an object, and we have been looking at how does the object respond to that push or pull. Well, what Newton's third law is telling us is that except on paper in a physics class, we can't have this force just acting on an object. Forces don't do that. Forces, the only way that a force can act upon an object is when there is an opposite force associated with a separate object. All right? So our little drawing here is showing an impossible system. We can have the orange on a cart, but it can't have a force just acting on it. So every time for moving forward, when we look at our systems, when we try to solve our problems, we need to be very specific about what our system is. So in this case, if we have an orange on a cart and there is a force applied, an external force, it will accelerate. And what this diagram is showing is only that external force. But in fact, the orange is getting pulled because the apple is pulling on it. Our system in this case is just looking at the orange. So this can't cancel. And in this case, the apple accelerates the orange. What if our system is different and it is the apple and the orange together? Well, now they are part of the same system because of how we defined it, and the force pair is internal. So we have this force and we have this force. There's no acceleration. And they're equal and opposite, and they cancel. The system does not accelerate. Well, let's make it a little bit more complicated. If our system is this, but there's also the ground underneath it, and an interaction between the floor and the feet of the apple, then there's an external friction force that is accelerating the whole system. This is a very different way to look at it, and don't be surprised if it doesn't make sense. We're going to keep working on this. So under what circumstance will this system move? Do we need to change the mass of the components of the members of the system? Do we need to change the mass of the orange, change the mass of the apple? Do we need to have an equal and opposite force from friction external to our system, or none of the above? None of the above. Common sense. The system moves when there is an equal and opposite force, when the apple is pushing against the floor and and moving the system forward. Might not just be foot power, it could be friction with the cartwheels, it could be wind. These forces could be from a variety of sources. Let's look at another one. Helicopter flying. So when the lift produced by the wings, or the rotor, pushing against the air, exceeds the force of gravity. So this is force due to gravity. This is force due to lift. What changes with the helicopter? Does the helicopter move downward? Does the helicopter move upward? Does it hover? Or do you not have enough information to answer that? This is a problem that we've had before. When the lift going upwards is greater than the pull going downwards, then we will have motion in this direction. We'll have acceleration in that direction. Let's look at another one. Hard to believe, but this bird does in fact fly. Does he fly because he flaps his wings? Is he pushing air down, which results in air pushing up? Is he hovering? Or is he inhaling and exhaling the air? How is it that the bird achieves the flight? Well, in fact, the bird is able to fly because with his wings, he does push down, and that moves air so that other air pushes him up. Have you ever played with balsa wood gliders? If you haven't, I'll get us some, and we can do that in class. Usually they are very light, or even a paper airplane. Suppose that you have two, a heavier one and a lighter one. The heavier one would have to, in order to achieve flight, the heavier glider have to push air downward with greater force, downward with the same force, downward with less force, or none of the above? What keeps the glider suspended? If the glider is going to need to have a greater mass suspended, then it's going to have to be designed so that its downward force is also greater. The air deflected has to equal the weight of the glider. All right. We will do a lot of this in class. We've got some simulations. We'll keep talking through it. This is the complicated part of this chapter. Let's move ahead, and our next talk will be about vectors, and will be good review for what you've been trying to do with vectors so far.